Hello, everybody. Welcome to, it's not quite a RAMI lesson, but this is more of a programming lesson. Today we're going to be learning about how command-based robots work in Java. And you really need to understand how this works if you're going to get anything else in the code. So let's start. So robots, with any program that you're going to write, you give it an input like a keyboard like a keyboard press, a joystick, a button, and or maybe like a sensor. So maybe you have like a rangefinder that senses the distance between something and a wall, or an encoder which senses the position of a motor, or a gyro that's like the angle that something's pointed at. Something like that. Could even be like a microphone for your computer. Anything like that's an input. So that's what you give the program, and then it'll give you an output. And outputs are usually like motors, servos, anything that really moves in relation to what you do, a monitor for your computer, LEDs that turn on and off to give you whatever status signal you want, speakers, buzzers, stuff like that. And the real question is, what happens between these two things, right? That's what the programmer's job is, because usually most people can figure out what's the input going to be. Usually, when we're driving a robot around a little controller or a button box or something like that, or even like an autonomous mode, we have the sensors mostly. And then we know what the outputs are going to be. That's what the game is. Like if we have to climb, or if we have to shoot a ball somewhere. And the programmer's job is to figure out what happens in the middle. Okay? So inputs of the code. Inputs that the robot receives is determined by the robot's state, which is teleop, autonomous, or maybe one of your own states. If it's in teleop mode, it gets input from humans and sensors. And in autonomous mode, it's usually pre-programmed instructions like drive forward this much, turn, do that. Sometimes it says there's maybe like a conditional in there, like if the distance is greater than 100, whatever 100 is, maybe inches, and turn, maybe, for example. So the flow chart, oh god, Sam edited things. So so this is basically kind of what you want to do. Ignore the advanced stuff. We're basically going to go around in this direction here. So the inputs, you press a button, right? What does the program do next? So the things in robot container, that detects inputs and calls commands. So what that means is it's saying it's detecting when you press a button, and then because you press the button, it calls a certain command, which is what the next thing is in the flowchart. So if we look at the VS Code here, we go to robot container. Robot container has it imports all your subsystems, but it also imports your it's an input in this case, your joystick. And then on that joystick you can declare buttons. So maybe you have your Xbox controller out and you have A, B, X, and Y on that. And then you just say maybe the A button's on button number 1, and we call it button name here. But then if we want to do something, we put the button bindings down here. So maybe this won't work, but for example, if we have button name and when it's pressed here, it'll call whatever this command is. I don't have it in here yet, but that's what you're going to be working on in this thing. So you're creating a joystick and then making a button off of that joystick, and then when that button is pressed, it calls something. That's what robot container is doing. So when you look into here, right, this detects it, calls a command, and then the command, I like to refer to it as the boss because it tells the subsystem what to do. The boss is saying, the command's saying basically, do this thing right now. The command doesn't really know how to do it, but it's telling the subsystem what to do, and the subsystem actually knows how to do it, like turn this pin on and this pin on, or whatever it needs to do that's a little bit lower down on the robot. So I'll give another example for that. If we go back to the code, a good command is arcade drive. Let's actually use one of these, a little bit simpler of a command here. Let's do drive distance. So this command takes in speed, inches, drivetrain, Doesn't really matter right now. All it's really doing is it's initializing, so it runs this code once when it's first set up, when it's first called by robot container. So in this case, it's setting x-axis speed to 0 and the z-axis rotate to 0. So it's setting your speed to 0. It's resetting your encoders so that the wheels are now at 0 position, so it can start counting. And then in execute, this is what it's going to loop over. It's going to set it to the speed you give it. Okay. So the speed you get it, not going to turn because it's driving a distance, so it shouldn't turn at all. And then it's going to end when it reaches that certain distance that you give it. But it doesn't know where the motors are, so it doesn't know how to tell the motors to turn at this thing. It's just telling the subsystem, in this case drivetrain, what to do. And in arcade drive, so it's taking in as M drive here, drivetrain. So this is the subsystem. It's calling the subsystem drive, and then it's calling it M drive in the global part. So it's saying in the drivetrain there's this thing called arcade drive, and I'm going to say go this speed and at this rotation. So if we go look into drivetrain, we're going to look for arcade drive. So let's see if we can find arcade drive. Here it is, arcade drive. It's taking in a speed of going forward and a speed of rotating. We don't want to rotate it at all, so this is always 0, at least in drive distance, but the speed is a certain amount. So then it's going to calculate the differential drive part, which is a built-in method that's not like declared, but it's going to be taking in this thing, sending it that speed. So you're just calling methods inside the subsystem from the command, if that makes sense. This is telling the subsystem what to do. The command is telling the subsystem what to do. Okay. So we got the command and we got the subsystem, which actually executes stuff, the worker. And then sometimes it goes to processing. That's usually for motors or servos, which have their own built-in kind of programs which tell it what to do. So with a servo, you have to send a PWM signal. But that PWM signal isn't like the power to drive the motor. There's a controller inside the servo that tells the power, how much power to give. Okay, but you're just sending a signal from the Rio, which is the main board, to that servo, if that makes sense. Oh, okay. So yeah, sometimes we'll just go straight to outputs, which is like an LED, which we can power with just like a signal pin. So if we have a pin on the ROMI, that's a 5-volt pin, one's ground, we can just turn on the 5-volt pin, and that should be enough power to power the LED. But sometimes like a super powerful motor, like we have on the robot, needs its own controller that'll give it extra power. So that's what the processing does. You don't have to worry about that much for the ROMIs, but that's what it is. So you go through this set of things to get your output, and that's what you have to program. And there's various ways of doing that. The autonomous mode is actually a little bit simpler, but just because you don't have to press a button to do things. You just set the robot's state, and then the robot does things automatically for you. So robot container usually chooses a startup routine. So that means you can give it different autonomous modes. So maybe like during a game, we have one thing where we want to maybe score balls into like a pit. So one of our autonomous is it's going out, turning, shooting a ball, and then going to pick up something. And maybe another autonomous mode is picking up maybe it's climber. So it'll go over to the climber station, grab something, and pull itself up. And maybe we have those two. And we can choose based on our teammates what to do. So that's what you do in the code. You choose which autonomous mode you want it to be on, and then that calls a command. Or, in more advanced cases, it does this, but we won't worry about that. And then something more interesting happens when the robot's running itself. The command and the subsystem are going to communicate with each other. So sometimes it's multiple subsystems, but usually the command is going to run until the subsystem tells it to stop. So command says, go forward. And then the command says, go forward until we find this amount. And then the subsystem tells it how far it's traveled. So it'll say, go forward. And then it says, it hasn't traveled far enough. Go forward. Hasn't traveled far enough. Go forward. Okay, we've reached our spot. and then the command ends, the subsystem ends, and then we get that output all throughout while this is communicating with each other, if that makes sense. So we got these things communicating, and then while they're communicating, we're getting an output, or maybe it's processing and then an output. Pretty much the same thing as the other one, just a little bit different. So now we're going to, I don't know if we're actually going to do this, but there's a game I made where I'm going to print out a sheet, and each person's going to get one of these things, and you basically become either like the command, the robot container, the input, or the output, or the subsystem too. And you basically, maybe the input person gives a number. In this case, human presses A, then the robot container has to do whatever they have to do, and then that sends it to the command, that sends it to the subsystem, and then you get an output. So this is just to kind of reinforce what each role of each thing is. So hopefully we'll get to do that at some point. Mainly though, that's pretty much it. And if you can understand this and actually finish lesson 1, which is right here, not lesson 1, sorry, lesson 2, this is actually doing exactly what we just talked about. It's putting it into practice. So this one is turning on an LED. So you're going to have to press a button on the keyboard. That's in a robot container. Robot container sends that to a command. The command tells the subsystem, turn on this LED. The subsystem then turns it on, and then the command ends, and we see the output of the LED turning on. And that's what you're going to be coding. So good luck with lesson 2. I'll walk you through it. And yeah.